Suppose R is a relation from A to B, S is a relation from B to C, and let's go ahead and draw that before we get too much further. We have sets A, B, and C, and then relations, not necessarily functions, R from A to B and S from B to C. Okay, and then we're assuming that the range of R and the domain of S are both this entire set B, and we're assuming that the composition of these two relations, right, S composed with R, which would go all the way from A to C, is actually a function. Okay. Now earlier we proved that in this scenario, S here, the relation S, is a function too, not necessarily R. Okay. And in this problem, we're going to assume that if this function S is also one-to-one, then R has to be a function. Okay. So let's sort of think through how we might prove this. In order to show that R is a function, we have to take an arbitrary element A in A, and we have to show that there exists a unique element in the set B such that A maps to B under R, okay, or such that AB is an element of R. So that there's an existence part and uniqueness part. For existence, we can use the fact that, and by the way, you can follow along in the proof over here as I explain this. For existence, we know that that S composed with R is a function, and so for this A there exists a unique C. I think I called it C naught over in the proof, so I'll write C naught over here in C such that A comma C naught is in S composed with R. Okay. And I actually don't need the uniqueness part right now, I just need the existence part, because if that is in S composed with R, then there must exist some, I'll call it B naught here in B, such that AB is in R and B naught C naught is in S, right? That's what it means to be in the composition. And well, now we have it, right? We have a B naught in B such that AB naught is in R. Okay, so that takes us up to this point in the proof, and now we got to show uniqueness. So let me delete a little bit of this. We have the same sort of arbitrary A here, and suppose we have a couple elements B1 and B2 in B, such that A maps to each of these under the relation R. Right, in other words, AB1 is in R and AB2 is in R. And we want to show that B1 and B2 actually have to be equal in order to prove uniqueness. Now, how can we use S here? Well, we know S is a function, right? And so we could just apply it to B1 and B2 to obtain, well, this is just S of B1 and this is S of B2. Okay. And now looking at the whole picture here, we have sort of A to B1 and B1 to S of B1. Put those together, you get that the ordered pair A comma S of B1 is in the composition, right? A comma S of B1 is in S composed with R. And similarly, putting together these two ordered pairs, you get that A comma S of B2 is also in the composition. Okay, and here's where we use the composition is a function. In particular, we use the uniqueness part of that definition to say that, well, if A maps to both of these guys under this function S composed with R, then they must actually be equal. Okay, and if those are equal, here's where we finally use the assumption that S is one-to-one, right? Because if we have two elements B1 and B2 which map to the same thing under S, which is one-to-one, then these inputs must be the same as well. Okay, and we're done. That was our goal, right? We were trying to show that if A mapped to each of these under R, then those two things had to be equal. That was the uniqueness. Okay. Now I did make a givens and goals table for this proof, but I think I'm actually not going to include it in the video. I think there's so much notation flying around in it that it confuses more than clarifying, really. And so at this point, I'd really like you to try to understand the proof at the level we've sort of described it here in terms of the intuitive picture, which is how one would typically sort of discover this overall strategy of the proof. And then in terms of how we've written it out here, which we have used the proof techniques and the definitions just as you would see in the givens and goals table, but we've really just highlighted the parts that are important for being able to understand what's going on. Okay.